A plane flies 720 kilometers north, 60 degrees east from Canton to Elgin. Then the plane flies southeast, so a hint, do not assume exactly southeast so you don't know the angle, 500 kilometers from Elgin to Naples. The plane flies due west back to Canton. So we want to draw a diagram that represents the problem. So let's start at the beginning. A plane flies 720 kilometers north, 60 degrees east, so that's our bearing. So north, 60 degrees east, so it's going north, east, so therefore we have the plane flying in this direction. So 60 degrees is here. So we can draw that vertical line, and the plane is flying north 60 degrees east from Canton to Elgin. So 60 degrees is here. Then the plane flies southeast. So southeast, so if you start from the middle again, southeast is this direction. So then just take that direction, you're going to start that at the end point here. So southeast here. And that flight is to Naples. We know that it's 500 kilometers. The other measurement we know is 720 kilometers here from Canton to Elgin. So 720, I'll put that here. Then the plane flies due west. So again, the words due west means exactly west here. And so I'll try to draw it a little bit better so it looks like it's directly west. And so that gives us more information. Okay, so let me just clean that up a little bit. North. Okay, so we want to know how many total kilometers does a plane fly. So we really want just this last measurement here. We have 720, 500. We need this last measurement. So we know that this angle is 60 degrees up here because that's our bearing, and it's always toward the vertical line, always toward the north-south line. So what we can figure out, now that we know this is due west, and this is that north line here, so due west and north line, then this is a 90-degree angle. So because it is 90 degrees, I'll put it on this side, it's the same on the other side, then therefore we could find out this angle in here. So 90 minus 60 tells us that this angle in here is 30 degrees. So now we really just want to find the measurement here. What we do have, if you think about it, we have, let's label this as C. C equals 500. Then we also have the measurement here, 720. So that is N. So we can use the law of sines to find out first this angle. And then once we find this angle, then we can figure out what the angle is on top. So I need to find angle N. So I'm going to say sine of N, because that's what we're trying to solve for, over N equals sine of C over the side C. So we're going to multiply N to both sides here. So sine N is sine of C. C is 30 degrees. And then multiply to N. That measurement is 720 kilometers. Then side C is 500 kilometers. So now we just plug it in our calculator. And you would get 0.72. So then you find the inverse. So second sine, second 0.7, and then second answer, or type in 0.72, we find that angle N is approximately 46.05 degrees. So 46.05 degrees. Now really, if I just get the angle on top here for E, then I could use law of sine again to find that last measurement. So to find E, angle E, we're going to take 180 minus 30 minus 46.05. And that angle is 103.95 degrees. So 103.95 degrees. So here, now we're just going to find E. side E, so E over sine E equals, and we can use C again because those are nice perfect numbers, not rounded. So C over sine C. So we're trying to solve for E, so let's multiply sine E to both sides. So now we have E equals C, which is 500 kilometers, times sine of angle E, which is the 103.95 degrees, all over sine of C, which is 30 degrees. So after plugging that in your calculator, you should find that E is approximately 970.51 kilometers. So that gives us this last leg here, 970.51 kilometers. So last, you just add the three sides together, 720 plus 500 plus 970.51, and you will get a total of 2,190.51 miles. Two dogs, Daisy and Brutus, are at a dog park. Daisy is running due east towards a ball that is 44 feet away. Daisy spots Brutus 38 degrees on her left, and this is from her line of sight to the ball. Brutus, also running towards the same ball, sees Daisy 67 degrees on his right, also from his line of sight to the ball. So let's draw a diagram. It's always very helpful to do that. So Daisy is running due east. So we know that's exactly east. So let's just draw a dot here. This is Daisy, due east. We know that that ball, so I'm just going to draw a circle for a ball, is 44 feet away. Now, Daisy spots Brutus 38 degrees on her left. So on her left is this direction here. So Brutus is somewhere over here. It's from her line of sight to the ball, right? So she's looking at the ball. And so she sees Brutus here. And so this angle here, so Daisy spots Brutus 38 degrees on her left from her line of sight to the ball, right? So here's the line of sight to the ball. To her left is this direction. So that gives us the angle here is 38 degrees. Now Brutus also running towards the same ball. So here's Brutus. He's running towards that ball. So I'm just going to complete the triangle here. Sees Daisy 67 degrees on his right, right? So if this is Brutus, the right side is going to be here. Okay, so I mean, as Daisy sees Brutus here, then Brutus would also see Daisy. So it's here. And so it's 67 degrees on his right, and again from his line of sight to the ball. So here's the line of sight to the ball. So the angle here to here is 67 degrees. That's probably always the hardest part is drawing the diagram. Now we can figure out the angle here. We know the sum of interior angles of a triangle is 180 degrees. So that's 180 minus 67 minus 38 degrees. And we find that that is 75 degrees. So what we're trying to find is the distance between the dogs. And so I don't want to use the same letter. So let me just go ahead and call this A. And we want to find this measurement A, right? A is just the distance between the dogs. So we can use law of sines. We know side B and angle B. So to find A, we're going to do A over sine of A is B over sine B. Multiply sine of A to both sides. Then substitute. So to find that distance A, we have side B, which is 44 feet, sine of angle A, which is 75 degrees, over sine of B, which is 67 degrees. Then once you plug it in your calculator, you will find the distance is approximately 46.17 feet apart.